Okay, so let's look at example 1. We're being asked to graph a square root function. The function that we're given to graph is y equals 1/2 times the square root of x. And we want to then state its domain and range. So the first thing we're going to do is we're going to come up with a list of values, very similar to how we worked our group warm-up. And we're going to come up with a list of x values we're going to plug in, and then we're going to plug it into our equation and get a list of y values out and plot those answers. So for x, we want to make sure that we pick numbers that are going to make sense with the function that we're given. So obviously if we're given the square root of x, we know right off the bat that we cannot plug negative numbers into x, because the square root of a negative number would give us an imaginary number. So we know right off the bat that we can only start with x being 0, because if we plug in 0, square root of 0 is obviously, and if we plug this in here, 1/2 times the square root of 0. Well, the square root of 0 is 0. 0 times 1/2 is 0. So we know right off the bat that if we plug in 0, that's our starting point, because we can't have negative numbers. We can plug in 0 and we get 0 back out. If we then move upwards, we want to pick a nice number that works with a square root. So 1 works really well, because the square root of 1 is just 1. And square root of 1 is 1 times 1/2 gives us 1/2. Now we can put 2 in there, but the square root of 2 is going to give us a not nice number. So let's pick a next number, maybe like a perfect square, that if we plug that in, we get a nice number back out. So if we plug in 4, square root of 4 we know is 2. So if we take 1/2 times the square root of 4, square root of 4 is 2. 1/2 times 2 gives us 1. If we plug in the next perfect square, which would be 9, 1/2 times the square root of 9, well, the square root of 9 is 3. 3 times 1/2 is 3.5, or we know that to be 1.5. If we go one more time, we can actually plug in 16, the next perfect square, because the square root of 16 is 4. 1/2 times 4 is 2. So over on the right hand side, we have a graph given here, and we can scale our graph so that it makes sense. In all of these cases, for the most part, we can fit the bulk of them on here without having to scale it. So we're going to go up by 1. So this gives us 1, 2, 3. This is 4, 5, 6, 7, 8. This gives us 9. And if moving up, we'll call this 1. We'll go by halves. So we'll go 0.5, 1, 1.5, and 2, just to scale it for us. And so if we just plot these points as ordered pairs, this is 0, 0, which is our origin, 1 and 1/2. So if we go at 1, we've got 1/2. At 4, we have y is 1. And at 9, we have 1.5, which is right here. If we connect our dots, we get our square root function that looks just like that. Our domain, because we can't plug in negative numbers, our domain is going to be x is greater than or equal to 0. Those are the only x values that will work. And because x is greater than or equal to 0, if we look on our graph, our y doesn't have any negative y values. We actually start at 0, 0, and we're going in the upwards direction, the upwards and right. So we're in quadrant 1. So we know our range is going to be y is greater than or equal to 0, for example 1.